Yeah, good morning, everybody. This is ASN Raju, and in the today's class, we would like to proceed towards the position or speed sensors. In the previous class, we have been discussed related to displacement sensors utilized in our mechatronic systems. Simultaneously, indeed, to find the different levels of the offenses, three offenses, that is liquid level offense, gaseous, and solid state of offenses. We have utilized different types of sensors. There is temperature type, level type, even the radiographic testing basis, optical basis of sensors at different considerations. But even in the dynamical constraints, dynamical considerations, these radiographic technologies are widely used indeed to grab the entire parameters that are being taking place in the level considerations at different phases of the mechatronic systems. Yeah, presently, indeed, to find out the velocity levels at different RPM rates, these position sensors or speed sensors plays a major important role here. So these are the sensors provide the information to the ECM, that is electronic communication modulation, communicating modulator, and it will be positioned at a statical position of a systemic device. Simultaneously, the systemic device, in the sense, the minute components have been manufactured, which is called as an G sensor, placed at the camshaft positioning of the particular sensor, and even that the crankshaft and the vehicle speed need to be measured. So we, apart with that particular shaft, these sensors will be placed naturally. So crankshaft position sensors and camshaft position sensors are one type of vehicle speed sensors which are utilized to grab the results related to the RPM, while the pickup coil type of sensors, these are called as pickup coils. So incrementing of the speeds and even the decrementing of the speeds, that is will be happened while starting the vehicle from uniform motion to the dynamical motion, and from coming back to the dynamical position to the uniform motion. So this type of sensors consists of an permanent magnetic coils, and these are mounted with respect to the gear allocations, and with the power supply that has been given to the sensors, it will be giving the feedback to the control unit, and hence that control will control signals will be grasped with respect to the monitoring actions, and the frequency levels will be getting modulated depending upon the pulses fluctuations in the dynamical motion of the vehicles, and will stabilize the frequency levels and generates the values in two different modes. First one, it is an analog mode and as well as the digital modes. So by utilizing the analog to digital converter as a component, by the incorporation of these ADC, analog to digital converter, in between these two different transformation zones, entire the values will be represented in the LCD display by transferring from analog to the digital characterization. So these are the pictorial representations of position or speed sensors, where it will be placed and at what dimensional accuracies the manufacturing of these position sensors need to be done, and the design or fabrication works have to be considered, and where the locations, these plays a major important role. where these particular sensors need to be installed within the automobile, and depending upon that criteria will be following the dimensional strategies, because in some places, in some of the components, it has to be strategically fixed away instead of utilizing the gasket. So we all aware of this gasket, that indeed to connect two different components at that particular alignment or joint, we'll be utilizing this gasket instead of happening the slipping factor. To reduce the slipping factor, this rubber material will be utilized as a gasket, indeed to have the grip very much in an action mode. It will be having a grip with a positive contactivity. So at that particular contact, by minuting the gauge length of that particular gasket, we will be utilizing this position or speed sensors at that particular jointal basis to give the high frequency variations, to eliminate the high frequency elevations at the dynamical position of the vehicles. So statistically, these sensors will be placed at a particular place and will be giving the feedback to the controlling module. So how this variates with respect to this particular sensors, the distance between the rotor and the pickup coil is very much critical. So this rotors uses this tooth teeth and is getting notched at that particular places. Also it will be getting a minute effect, because the slipping factor may be occurring at that particular teeth levels, and slippage may be getting happen due to the non-variable levels. So if the variable levels are existing, upon shifting of the gears, the alignment of the teeth may get deferred. So instead of getting those slippage factors, need to take a proper care in the exact timing chain factor. We'll be calling as a timing chain factor at the shifting levels of the gears. And we'll be separating these two different linkages, that is permanent shaft, driving shaft, and driven shaft, with respect to a device called clutch. So application of the clutch will separate this contact between this driving wheel shaft and the driven wheel shaft. So at that particular alignment, the teeth may be getting mismatched. So those also will be getting identified with these particular sensors. So hoping the best, it is an permanent fixation as per the design criteria, and these sensors generate AC voltage power supply and do not need any external power supply indeed to operate within the particular system. This is why it's or twisted and shielded to prevent electrical interference from disrupting the signal. So statistically, it will be getting fixed at a particular joint. So hence, there will not be any fluctuations within the voltage levels. And here, when it has been, we know that it has been positioned of the at the camshaft, the ECM, electron chemical machining process, it can determine, ECM in sense electrochemical machining process can determine that cylindrical number and compression stroke. And the signals will be getting generated signals, AC signals is directly proportional to the camshaft speed also even. So working nature is an automatically generates itself the AC power supply upon momenting of these particular two different linkages of the tooth. At that particular level, the generated power will be utilized, and the sensor it itself generates the AC power supply for its own operation, and senses the entire strategy that has been commenced as per the program given. The task will be getting performed, and you'll give the feedback signal to the controller. Yeah, variable reluctance sensor. Here is the operational mode. So pickup coil, variable reluctance, sensor. So hence here this is the rotor rotating with respect to the shaft. Here the sensor is being placed. So upon hailing, upon in contact with respect to the permanent magnet is getting fixed over here, and we all know that the eddy currents will be getting produced, or inductance capacity or inductance, mutual inductance will be getting done upon the iron rotation to the permanent magnetic device, and hence the field will be getting generated. So that generated field will be captured by this ECM, electrical chemical ECM process, and these voltage fluctuations will be captured with respect to the frequency modulator and next stabilizes it in such a way selfly the electrical power supply will be utilized by this sorry a sensor, and itself it will be used for its own functioning and will send the feedback signal to the main device. So variable value position sensors. So some of the valves timing systems, yeah, we have already discussed this valve timing factors. So valve timing factor is much more important to a particular alignments or for a dynamic motion of a vehicles. So if at all it has been deviated, sudden stoppage or sudden halting of that particular system will be getting commenced, or else even can be dragged on to the subsequent levels later on furtherly also. This camshaft position sensor, the variable value position sensor. Yeah, we'll be seeing the difference between these two subsystems. Here is the pictorial representation. So hence the timing rotor has been fixed over here. By this, upon rotational factor, the chain cam is fixture, and here the cam position sensor has been placed over here, and upon rotation of this a permanent magnetic rotor will be rotating with a heavy speed as per the orientation of this particular cam wheel will be equals to the 20 rotations of this rotor sensor rotor, and high amount of EMF will be produced that will be utilized for its own operation and will give the feedback signal with the help of this chemical position. So hence this camshaft position sensor, it itself generates the high voltage for its own operational process. So there is no any need of a DC power supply here, and as well as from it can give the feedback directly towards the systemic zone, that is main system. Here camshaft position sensors towards the NE sensor. So now this signal sensor. This uses the camshaft position signal to determine the RPM, camshaft position, and engine misfire also. The signal is referred to NE signal. So we'll be calling as an null error sensor. Null or error sensor. So the signal referred to as NE signals. So main parameter that determines engine RPM is crankshaft position and engine misfire. The the NE signal combines with respect to the G signals. There is a main signals generating signal indicates that the cylinder that is on compression, and ECM can be determined by its programming. So hence the programming is being given to the sensor that is operated from the processor. We'll see the actions at section 3, that is on ignition systems. So this is the position at the engine level of the at the engine part of the any kind of engine part of the vehicles. So hence here it will be getting position. So intake subsystem, and next first one in stroke, next one compression stroke, next one power stroke, next one exhaust stroke. So at the level of the third stroke it gets highlighted, and next crankshaft position will be managed, and timing chain will be identified before itself, whether that the failure of engine has been commenced or not. So moving on to the next one, VSS, vehicle speed sensor. So how the vehicle speed is being identified, and how it can be monitored. So in the mechatronic field, we all know that if the speed of that particular vehicle has been increasing, simultaneously it has to be decreased depending upon the situations. Let us consider a simple example. If the vehicle is being driven by a driver, when he visualizes that he is very much nearer to the speed breaker, he will reduce the speed, and shifting of the gears will be modulated by himself. But the major mechatronic system is not a criteria of this. So there is no any involvement of the human beings here. So automatically the speed has to be reduced, the gear shifting need to be done, and depending upon that particular system, it has to be increased furtherly. So manual basis of system need to be minuted here. So here is the question. By this system, we have in the companies, many of the companies, manufacturing, car manufacturing or automobile manufacturing companies incorporated these particular systems in the ECMs, such as that is ABS system, anti-lock braking system, and it consults towards the EWD. And advanced features are being developed in this anti-lock braking system, right? So the mounting factors that has been taken for the transaxi and transmission. Here, the pulse will be generating by the sensor, and that will be sending a signal to a bus interface system that is being connecting a combination with respect to a combination meter, and that will give the feedback signal to the ECM, and this ECM will be directly in connected with respect to the controller, and controller will take the necessary action indeed to decrease the speed or indeed to increase the speed, nothing but the acceleration process. So depending upon the acceleration process, simultaneously this cam shaft timing chain need to be changed by the programming given by this particular processor, and that processor will be guided from the controller. So depending upon the feedback done by this particular sensor, simultaneously the actions will be or guidance will be given to the processor from the controller indeed to increase the speed or decrease the speed. So depending upon increment or decrement, this timing chain plays a major important role, because the shifting factors need to be done automatically without human involvement, and at that particular time the alignment of the gears need to be done in a particular features, particular or even contact ratio should be very much uh, constrictive. A reed switch type, yeah, the reed switch type is driven by the speedometer cable, which will be visualizing generally in our automobiles also. Yes, it is the main component magnetic, the reed switch, and directly that speedometer cable will be connected to the speedometer, which will be indicating with respect to the digital display or else the analog display. Yeah, here it is the reed switch. At this particular rotor, counter positioning perpendicularly, the sensor will be getting placed over it. Upon that particular rotating aspect, the sensor also will be rotating with respect to the speedometer cable, and that cable will be guided towards the speedometer channel, and this reading switch will generate the electrical pulses as PDs and ECMs, electrochemical electron controller machine, electric controlling machine. And this electrical control machine will be highlighting the display channels either in analog as well as in digital format. If the ADC process has been considered or equipment is getting set up with respect to the ADC analog to digital mode, simultaneously it will be displaying in the digital display. Yeah. Coming to a conclusion of these speed sensors, the major component that we have been discussed in the lecture is that electrical circuit. So this electrical circuit need to be designed with a particular guidance system or sequence of instructions that has been framed in the programming nature. That programming need to be installed or that it be debugged to the microprocessor. That microprocessor need to be guided with respect to the microcontroller, and depending upon the sensor's feedback, the controller will grasp the corresponding signals as an feedback. So apart with that, or with corresponding to that particular feedback language, controller will guide the processor to execute a particular sequence of steps or shifting of some of the steps and next steps in the program, and next what are the necessary steps of the program need to be executed immediately at that particular time. So that will be guiding from the controller to the processor, and then processor to the here timing change. So the timing change is changing levels at the different levels and different stages for the different purposes will be monitored only by that particular program given in a set of instructions format, and that will be changed or executed as per the sensor feedback given to the ECM process, electron controlling monitoring controller or modeling module. Right, using this approach, off the shelf instructions such as NI660X, E series and S series devices and field point and compact field point modules can extract accurate frequency and phase information from high speed sensor signals. So high speed sensors, when this is utilized for naturally, these are the electrical systems ECM, that is ECMs, are utilized for sports vehicles, which are very much fast enough and moving with an highest velocity ratio. So, how many times it has been considered, and how many times it has to be overcome? So, automatical counting need to be done, and automatically reset of that particular counters also need to be done, because if only in the programming, if or in the programming the instructions that has been giving to the electrical circuit is limited to a particular timings, and hence the counter will count that particular times, and next later on it will be getting dismantled. So because if it has been counted for 10 number of times, simultaneously if the 11th time it need to be considered the counting, the initial stage of values need to be erased automatically. So the memory will be getting accessed for storing only up to 10 different values. If the 11th value need to be observed or counted as per the protocol or as per the program or as per the feedback given by the sensors to the controller given the signals to the processor to execute a particular steps, and that will be guiding this particular timing change to be getting deferred, and that value to be noted as an 11th time, initial value will be getting deleted automatically. So that will be monitored by these counters. and this will be having a mutual contactivity to that particular electrical circuit, right, which will be utilizing in a number of automobiles, even the aerospace and mission monitoring applications. Done. We'll be continuing in the next class. Thank you.